Alright, welcome back to Arithmetic and Maths. This time we're going to look at some index laws. So here I'm looking at the Year 9 revision sheet for index laws. Notice here I have given you levels for each question. Your first level is single index law application. Level 2 is I'm applying two laws combined together. Level 3 is 3. And level 4, those who are going for that A standard, 4 index laws or more combined together. And then we've got scientific notation questions and a few worded problems. This is all simple familiar rate related, so if you can do all this, you can get a grade mark on your simple familiar. Alright, let's have a look at the single index laws. Before I do, I'm gonna write down a few things. Alright, in your exam you are gonna get the formulas for these index laws. Since I don't have them with me, I've just written them here. We've got the first rule, which is multiplication, which says if we're multiplying indices, we add the powers. If we're dividing, we take the powers. Anything to the power of 0 is equal to 1. Power of a power means we multiply those indices together. And if it's a negative power, it does not mean a negative number. It means we write it as 1 over a to the positive nth power. And with that, let's have a look at our level 1 questions. Alright, first question, we've got x to the power 4 multiplied by x to the power 7. Again, we're multiplying. First law says we add those powers. So that's going to be 4 plus 7, which is x to the 11th. Question 2. I've got a to the 12th divided by a to the 5th. Again, second law says I'm taking away those powers. So this is going to be a to the 12th, take 5, which is a to the 7th. Our third question is m to the 3rd power, power to 4. Again, that's multiplying powers. We know from up here, when we have a power of a power, we multiply the powers. So here we're going to do m to the power 3 times 4, which is m to the 12th power. Our fourth one is p to the 0. We know anything to the power 0 is 1. And our fifth one is p. Sorry, I can't read the alphabet. That's a q. Q to the negative 3rd. If it's negative, remember we want to represent it as a positive power, which means if we go back up to a law, it's always going to be 1 over that base with the positive power. So coming back here, that's 1 over q with a positive power of 3. And that's the level 1 questions done. Now we're going to move on to level 2, where we combine two index laws. Alright, our level 2 question is x to the 5th times x to the negative 2. So again, we're multiplying, so we're going to add those powers together. So we're going to do x to the 5th plus x to the negative 2. Again, I'm putting it in a bracket so I know there's a positive and negative that I need to solve. And I know from my work in year 8 that positive and a negative together makes a negative, so this is going to be take 2, and now we take the powers away, which gives us 3. Question 12. again we have a to the 8th divided by a to a negative power. So again, we're going to follow the same processes, but this time, since it's divide, I'm going to take away my powers. So it's going to be a to the 8th take away negative 3. We know from year 8 that two negatives together makes a positive, so that's 8 plus 3, which is a to the 11th. Not 13, I'm going to do 14. I've got p to the 0th power times p to the negative 5. Alright, there are two ways to do this. I'm going to use multiplication rule. So we know from multiplying we can just add those powers together. So that's going to be 0 plus negative 5, which gives us p. A positive and a negative makes a negative, so 0 take 5, which is p to the negative 5. A negative indice we like to represent as a positive indice, so that's 1 over p with a positive power of 5. That's one way we can do it. I'm going to show you the other way because both ways are correct. It's up to you which way you want to do it. Alright, the second way we can do it. If we apply the 0 rule, we know that p to the 0 is 1, and we're going to multiply that by p to the negative 5. 1 times p to the negative 5th power, well that's p to the negative 5th power. And we know that anything to the negative power, we write it as 1 over p to the positive power. So, again, either way is correct. It's up to you which one you want to use. Some people understand this, some people like this. Both are correct. It's up to you. Question 15. Again, I don't know my p's from q's. Let's try that again. Q to the negative 4 divided by q squared. Again, since we're dividing, we're going to take those powers away, because that's my law here. We're dividing, we take the powers. So we're going to have q to the negative 4 take positive 2. We know that negative 4 take 2, well that's negative 6. And again, since we've got a negative power, we're going to put that 1 over the base of q with a positive power of 6. Alright, next question. Level 3. We're going to combine 3 index laws. I'm going to do 23 on this revision sheet, because that gets a bit funky. Because we got m to the 4th all squared, and then we're going to divide by m to the 5th times m to the negative 1. When you've got power over power, dividing powers, multiplying powers, first thing we need to do is the brackets, because bombdads we do brackets first. So let's do power over power, which says I'm going to multiply the the outside power by whatever's inside. So that's going to be m to the power 4 times 2 divide m to the power 5, we haven't touched that yet, times m to the power negative 1. Haven't done anything with this, I'm just going to leave it there. Here we know that 4 times 2 is 8, and now I'm going to divide by m to the 5th times m to the negative 1. Again, with bombdads, we work from left to right, so division comes first. We got to divide first, then that answer will multiply by negative 1, m to the negative 1. When we divide, we know that we're going to take those powers away, so that's going to be 8 take away 5 times m to the negative 1. Again, haven't done anything with this, leave it there. That gives you m to the 3rd times m to the negative 1. Now we're multiplying. We know from our rule when we multiply powers, we add those powers together. So we're going to go m to the power 3 plus negative 1. Which when we simplify is the same as saying 3 take 1. Positive and negative is a negative. 3 take 1 is 2, so our answer is m squared. Our next question we're going to look at is 29. We've got t to the negative 3 all squared times t to the 4th. Again, just like up here, we're going to do the brackets first. So I'm going to multiply 2 by the power that's on the inside. So we're going to have t to the negative 3 times 2 times t to the 4th. Simplify that. We've got negative 2 times 3 is, negative 3 times 2 is negative 6 times t to the 4th. Now we're applying the multiplication rule for powers, which says we add those powers together. So t to the negative 6 plus 4, which gives us t to the negative 2. So t to the negative 2 power, if we've got a negative power, we want to represent it as a positive. So I'm going to go place it over 1. Base is on the bottom. That negative power now becomes positive. So it's 1 over t squared. At level 4, we are going to combine all the index laws we can. So we've got power of a power, divide powers, multiply powers, power of 0. So first step, just like before, BOMDAS says we gotta do the brackets. So I'm gonna take that 2 multiplied by the inside power. So y to the 4th times 2. The rest of this we haven't touched. I'm gonna write it down. So divide y to the 5th times y to the negative 3 times y to the 0. We're gonna simplify that. So 4 times 2 gives us 8. Now I'm gonna divide y to the 5th times y to the negative 3 times y to the 0. Again, haven't touched any of this bit, I'm just writing it down. Next, BOMDAS says division or multiply. If there's no brackets anywhere, we work left to right, do what comes first. Division comes first, so we are going to divide those powers. Dividing powers means we take those indices away. So we're going to do 8 take 5 times y to the negative 3 times y to the 0. Again, haven't touched it, leave it there. 8 take 5 gives us 3, and we're going to multiply by negative 3. So y to the negative 3 times y to the 0. Now all we're doing is multiplying, so I'm going to add 3, negative 3 and 0 together. So 3 plus negative 3 plus 0. We know a negative and a positive is a negative, so this is going to be y to the power 3 take 3 plus 0, which simplifies to y to the 0 plus 0 is still y to the 0, and y to the 0 is 1. And you can't see that, so I'm going to move that up. So again, 3 take 3. This bit here simplifies to a negative. 3 take 3 is 0. 0 plus 0 is 0. Anything to the power 0 is 1. So we started here, and we've come down to 1. Alright, we are going to move on to scientific notation. Before we do that, we're going to have a quick sponsorship deal come through, and last year was Golden Tash. This year, we're moving up in the world. We've got Bundaberg drinks, and this time it's Burgundy Cream and Soda. If you haven't tried it, do try it. It's a great drink. Thanks to Bundaberg. Alright, scientific notation. Our first question is 4 times 10 to the third times 5 times 10 to the 6th. Notice how there was no times, but I said multiply, because if we've got nothing between our brackets, we assume it's a multiply. So now that we have that, we're gonna, like we do with these, whether we have the same variable or mixed variable, we're going to combine like terms. So we know that 2 of our like terms here are 4 and 5, so we can put 4 times 5 together, and we can put 10 to the power 3 times 10 to the power 6 together. So 4 times 5 is 20 times 10 to the power 3, 10 to the power 6. Well, we're multiplying, so I can add those powers together. So 10 to the power 3 plus 6, which means this is going to be 20 times 10 to the 9th power. Alright, I thought we were done, but something didn't sit right with me about this, and it's the number 20 here. Remember, in scientific notation, we want a number between 0 and 10. 20 is above 10. So we need to move the decimal point, which is on the corner here, and we need to move it back here 1 space, which means we need 2.0. And if we move the decimal point back, we're going to have to increase this power by 1, so it's 10 to the power 10. So 2.0 times 10 to the 10th is the same as saying 20 times 10 to the 9th. It's just scientific notation. We need a number between 0 and 10. Alright, again, we're going to follow the same process. Group like terms, put them together. 6.2 times 3, and then our powers of 10, they're like terms, so put them together. 10 to the power 5 times 10 to the power negative 2. We're going to do 6.2 times 3, which is 18.6 times, again, powers of 10, multiplying. We're going to add those powers together, so 10 to the 5th plus negative 2, which means we've got 18.6 times 10 to the 5th, take positive and a negative is negative, take 2, which is 18.6 times 10 to the 3rd power. Again, we can't have a number greater than 10, so that decimal point I'm going to have to move back by 1. That was a terrible arrow, which means this power on the end, we're going to increase that by 1, so 1.86 times 10 to the 4th. And that's your answer for that one. Alright, the next question is 1.2 times 10 to the negative 7 divided by 4.4 times 10 to the negative 3. But before I do that, something I want to do this year, for people who have watched the video up to this point, I'm going to issue you a challenge. Now, for anyone who knows Mr. Matthews, he loves a good brain teaser, a riddle, making people confused. And if you ever come into the JSP staff room and you knock on the door and he answers, normally he'll ask you if you're here for a motorbike, just to confuse you when you enter the staff room. So your challenge if you accept it and choose to complete it. It's if you ever come to the JSB staff room and Mr. Matthews asks you if you're here for the motorbike, and you have to ask him, sir, do you know how much I can get it for? Bonus points if you've printed out a photo of a motorbike and come prepared with it, just to return the favor and confuse Mr. Matthews. But you cannot tell other people that this is something I've issued in this video. You cannot tell other staff, or you definitely can't tell Mr. Matthews. It's just a little bit of fun, and see how long it takes for Sir to catch on. Anyways, back to the maths. We've got this question. We're going to divide like terms. So we've got 1.2 divide 4 times 10 to the negative 7 divided by 10 to the negative 3rd. So here, do each component. So first we're going to do 1.2 divided by 4, which is 0.3 times, and now again we're dividing powers, so we're going to take those numbers away. So I've got 10 to the negative 7, take negative 3. If we simplify it further, that's 10 to the negative 7, 2 negatives make a positive, so that's a plus 3. 0.3 times negative 7 plus 3, that's going to give us negative 4. Now, since it's scientific notation, you don't have to put that as 1 over 10 to the 4th. This is your final answer. You don't have to increase or decrease that power, because that number is between 0 and 10. Alright, the last thing I'm going to do in this video, it's some worded problems on using indices and scientific notation. Alright, so we're going to focus on the first 3 problems. It's important to note that in this worksheet, since it's on a Word document, every time you see something like this, that means 10 to the 7th, or something to the power. So this is 4.2 times 10 to the 7th. Alright, now that you know that, the question is, a satellite orbits the Earth in a circular path with a radius of 4.2 times 10 to the 7th meters. Calculate the circumference of the orbit in scientific notation. And since we're really nice to you, I've given you the formula for circumference of a circle. So let's plug in what we know. You know the circumference of a formula, of a circle formula, 2 times pi times r. We know the radius of the circle, so that's going to be 2 times pi times 4.2 times 10 to the 7th. Again, you can put that straight into your calculator and get the answer. So let's go ahead and do that. So that gives us 2, 6, 3, 8, 9, 3, 7, 8, 2.9. But the question did want us to represent our answer in scientific notation. So we're going to have to bring that decimal point back to 2.6. So that's 1, 2, 3, 4, 5, 6, 7, 8 jumps that the decimal point's got to make. So this is going to be 2.6 3893782 9 times 10 to the 8th power. Oh, and it's meters. And question 2, we're going to work out the area using index laws. So the question is the width of a rectangle. So let's draw our rectangle just to give us some visual clarity. So the width of our rectangle is 5x squared y, and the length of our rectangle is 4x cubed y to the 4th. Again, that's how that should be written. It's just on Word, you have that little caret thing. Now we know the area of a rectangle is length times the width. So our length is 4x cubed y to the 4th times our width 5x squared y. Now when we multiply, we're going to collect or group like terms to make it easier. So 4 times 5 are like terms, x cubed times x squared, and then y to the 4th times y. We know 4 times 5 is 20. Our x terms here, since we're multiplying, we're going to add those powers. So x3 plus 2 times y. As I've always said, if it doesn't have a power on y or any variable, it is 1. Again, we're multiplying, so we're going to add those powers. 4 plus 1. So that gives us 20. X to the 5th, y to the 5th. And that's our answers, because we don't have any units. Alright, that's the end of this video. If you need more help, I would say do this revision sheet, go through it, come see me if you need more assistance, and hopefully you'll be good for your exam if you've done this entire revision sheet. And if you get a chance to go to the channel and check if the new YouTube banner has come up, can someone tell me if it's up? It's new, I just want to know if it works. And with that, I'll leave you with some Drake to lead us out.